All right, so now the factor theorem. The factor theorem states that if a polynomial f of x can be divided evenly by another polynomial d of x, that means they have a remainder of 0, then the divisor d of x is a factor of the polynomial f of x. So determining that is pretty simple. We're going to do an example here. I have f of x equals x cubed minus x squared minus 14x plus 24. And which of the following polynomials is a factor of f of x? Well, to do that, all we need to do is divide f of x by the expression here, and if I get a remainder of 0, then x plus 1 is a factor of f of x, and if I don't get a remainder of 0, then it's not. And if x minus 3, when I divide f of x by x minus 3, if I get a remainder of 0, then x minus 3 is a factor. If not, then it's not a factor. So you can use synthetic division if you prefer. I'm going to go ahead and use long division for this one because I just feel like you should be practicing both of those. So let me see here. All right, so x to the third minus x squared minus 14x plus 24 divided by x minus 1. X minus 1 does not go into x cubed, so x cubed minus x squared. Now, what up here can I multiply by x to get x cubed? Well, that's going to be x squared. So x squared times x minus 1 is x to the third x squared times x is x to the third. X squared times negative 1 is negative x squared. Then I'll subtract down negative x, the first two cancel, and then negative x squared minus negative x squared is actually 0. I'll bring down my negative 14x, and let's see what we've got here. What linear term can I multiply by x to get a 0x squared? Well, that's got to be a 0x. So plus 0x. 0x times x is 0x squared. And 0x times negative 1 is 0. I'll subtract down negative 14x minus negative 0. So negative 14x minus 0 is going to be negative 14x. Bring down my 24 and see what I get here. X minus 1, it's going to get multiplied by negative 14. Negative 14 on the top times x is negative 14x, and negative 14 times negative 1 is positive 14, and then I'm going to subtract down. The first two cancel, and then I get 24 minus 14 is 10, so a remainder of 10. And now, if I go back up to the top and I read my factor theorem, it says, if the polynomial divides evenly by another polynomial, then that is a factor. So, is x plus 1 a factor of f of x? And we would say not a factor because the remainder is not 0. Did not divide evenly. All right, and for sake of time, I'll do B, but I'm going to do B using synthetic division. So remember, when we use synthetic division, we have to find the 0. We place the value that makes that factor equal to 0 on the outside. And then I'm going to set up my bracket for my synthetic division. And now I'll start to write down those coefficients. 1, -1, -14, and 24, and do some synthetic division. So bring down my 1. 1 times 3 is 3. Add down, I get 2. 3 times 2 is 6. Add down, -8. 3 times -8 is -24. And when I add down, I get 0. So f of x divided by x minus 3 equals x squared plus 2x minus 8, remainder 0. So is x minus 3 a factor of f of x? And we would say, yes, it is a factor. And because we got a remainder of 0. So technically I could write f of x equals x minus 3 times x squared plus 2x minus 8, using a little bit of multiplication. I basically just said, okay, if I multiply both sides by x minus 3 here, we can help factor that polynomial. Okay? I think that's it. I hope you don't have any questions. If you do, you can post them to the Google community, and hopefully somebody will be able to answer your questions if I can. So, thanks. The next kind of problem that we're going to do is using the factor and the remainder theorem kind of in combination. And my problem says determine the value of a if f of x is a factor of g of x. Okay, so what I'm really trying to do is I'm trying to find what is that a value, right? That's my ultimate goal. What value can I put in there, what number? And when we set this up, since we know that f of x is a factor of g of x, when I divide g of x divided by f of x, I know that I'm going to get some function with a remainder of 0. And we're going to actually use this remainder of 0 piece as, we're going to use that to our advantage. So I'll go ahead and set up the synthetic division. Do my upside down bracket, and I'm going to do the coefficients of g of x. 1, 2, a, -8, and -3. So 1, 2, a, that's what we're trying to find, -8, and -3. Okay? Now, on the outside, remember, I look at what I'm dividing by, which is x minus 3, and I write down the 0 that relates to that factor. So positive 3 relates to that factor. And now I'm going to start my synthetic division. Now I'm not going to be able to do the whole thing because I have this a value and I won't be able to add that down. So first I bring down my 1 and then I multiply. 3 times 1 is 3. And now I'll add those two. 2 plus 3 is 5. Now I have 5 times 3. 5 times 3 is 15. 5 times 3 is 15. And now when I add down, you notice I can't really add anything there. I'm kind of stuck. So what I'm going to do is now I'm going to use this fact about our two functions. I know that f of x divides g of x evenly, so I know my remainder is going to be 0. And if I know the remainder is 0, then I should be able to figure out what number is going to go right there. -3 plus what will give me a 0? And hopefully you can see that that's going to be a positive 3. So positive 3 plus negative 3 would give me the 0, and now I'm going to work backwards. What number here multiplies by the outside so that I would get a positive 3? 3 times what? Now I'm trying to figure out what goes here to get 3. And 3 times 1 is 3. Once I've got that figured out, now I'm still working backwards, and I go, okay, negative 8 plus what is equal to 1? Negative 8 plus what is equal to positive 1? And you should get a 9. And I'm going to continue. 9 times, or I'm sorry, how do I multiply to 9 using a 3? 3 times what value equals 9? 3 times what value equals 9? Well, that's 3 times 3. 3 times 3 is 9. And now you should have this right here. And I'm going to use that. I'm just going to set up an equation. A plus 15 equals 3. A plus 3 equals 15. So now if I subtract 15 from both sides, you'll see that I get A equals negative 12. So this was the value A that if I plug it in right here, I know that f of x is now a factor of g of x, so I have found the A value, negative 12. So take a few minutes, write down a short summary about the factor theorem and how you use it. What are the different things that you learned about the factor theorem? And if you have any questions, post them to our Google community, and hopefully somebody will be able to answer them for you. Thanks.